Multiple inheritance in Godot. Why would you want that? Because we want to make an RTS. Which commonly uses a lot of different units, which have a mixture of common and unique behaviors. For instance, a farmer unit moves to work on a farm, and a soldier moves to attack its enemy. Now, we could start the code, and we have a code which works for our farmer, and then we make the code for a soldier. Now, here comes the issue. If you start doing it each time, the code for a separate unit, isolated, so each time you do a separate code for the units, you will need to eventually group them together. And here's one of the ways you could do it. So let's say that both units, which have a common attribute, which is going to be the move functionality. So we could join those scripts together and create a single script, which we could call it a unit code script. And it could move our units so the soldier will be able to move and attack its enemies, and the farmer unit will be able to move and gather their resources. What if you wanted to add a healing unit? So something like a monk, a repairman, something like that. Well, we could say just add a healing function and continue the code, and create some logic that applies only to the healing unit. However, here's an issue. We're making an RTS, so probably we're going to have a lot of different stuff happening at the same time. And if we try to keep all of those stuff condensed in a single script, that will not be a good idea, and here's why. Supposedly that our entire script is a single one for all the units in the game. So all these different functions and features of the script will make it do too much things at once, and it's going to be a mess to understand, to modify the code, and to maintain it. Not even to say, if you find a bug somewhere to fix, it will be a nightmare because you don't know which parts are working and which parts are not, because everything is a single mess. So this, while it's better than the previous solution of doing the code separately, it's still not an ideal situation. But maybe we can split them in groups, and so we can reuse the code for things that make sense. For instance, we can make codes for the building and for the units, and this potentially can work. However, you eventually will find a common issue. You have the same functionality on both different scripts. So for instance, if we made this on Godot, both the building and the units have hit points and armor. You could copy the code, you could copy and paste the code on both cases. However, anytime you change it, you're going to have to update them manually again. And this isn't a great solution. So, what if we could separate the behaviors inside of Godot in separate modules? So for instance, we could do a separate modules. A building will only need hit points and armor. A soldier is going to need hit points, armor, movement, and attack abilities. A farmer is going to need hit points, movement, and gather. And a turret is only going to need hit points, armor, and attack abilities. So using this idea of modules, we can make specialized units just by selecting a few modules. In our example here, we just made a turret by selecting a armor module, an attack module, and a hit points module. In theory, this should work quite well for a turret. So the idea is to make a lot of different modules which we can later use together through a system we will have to create and maintain. This is an ideal situation, and it is what we are going to try to achieve inside Godot for our RTS project. So let's see our first method here, method A I'm going to call it, which is going to talk about extended single inheritance. So, all game objects will inherit for their ancestors everything they need. For instance, a soldier here, we're going to call it Josh Soldier, is going to inherit attack unit class, and which is going to inherit the base unit class. For instance, in GD script, this is what it's going to look like. We have here an extends base unit. The current class here which are in the script is this one, attack unit, so it should be this one in this case. And it's extending from the base unit, which is this one. So what this does is allow us to separate some behaviors here. For instance, our final code script, which is called the Josh Soldier unit, could hold some custom data, which could be its name, its HP, its attack, move speed, and view range. And our attack unit could hold some attack methods like move and attack, move formation, patrol, etc. And our base unit can hold the base structure for all units, so no base units should give in any default names. we're going to assign the final names through the final chain. So here Josh soldier unit should hold the unit name, the HP values, the attack, etc. And we can even change this later. However, here we are facing another issue, and here's why. So mixing classes is impossible in Godot. That is due to the single inheritance method that Godot uses, which only allows you to inherit for another script class just a single one. So in this situation we have here two scripts, an anti-air turret and a guard tower. Both are inheriting for a defense building code, which could be an attack, hit points, and armor code. And here we have a civilian shelter and a grain silo. Both are inheriting the civilian building class. So it could have stuff like stockpiles, stock amount, stock type, etc. However, in Godot, it is not possible to achieve the following. You cannot extend from the defensive building and at the same time the civilian building. So if we want, for instance, create a civilian building that have a attack defense pattern like a turret upgrade to a building, we cannot do so. So if we wanted to keep this system and create a civilian shelter with anti-air defenses like a mixture of the defensive building with the civilian building, we'll need to create a third type, a third class, a defensive civilian building. And this is an issue, because we are essentially just copying the code from the defensive building and the civilian building and mixing it inside the script. That manual work is going to bite your ass later, because whenever you change the defensive building code, you will have to come here and update this as well. This code does not belong to the defensive building, so any changes you make to the defensive building, you are going to have to access the defensive civilian building script and update them manually. And this code duplication is not sustainable whatsoever. While here we're just mixing two common builds, so supposedly you want to create more unique types of mixtures between classes, you have to keep duplicating codes to paste them together just so you can inherit it for a single type. And this is not the ideal solution. So that is the main issue for using the method A, which is the single inheritance method. So let's go and talk about method B. So method B will be a node component inheritance. So you probably have seen this from some tutorials, and this works better than method A in my opinion. So all units are made from a set of behaviors defined in different nodes, and they work like the component system which we saw previously, so the idea is still the same. You're just applying them through a different method. Instead of doing the single inheritance method, now we are doing it through node scripts. So the idea is still the same, we're just changing how we apply the modules. And using this method, you would apply with different nodes. So depending on your project, this method could work quite well. The idea is still the same. You would have a couple of units, which will grab a couple of logic nodes. So the idea is that logic nodes will be these nodes right here, which represents the idea of modules. Our previous issue we had on the earlier method, which was to mix those both. We can see here that it will be a simple way of doing it, just grabbing the anti-air attack with the attack functionality and the civilian shelter. We would achieve the behavior we want, a civilian shelter with anti-air defenses. So this system works well. Now here's the issue of using the system, and this is only relevant if you make a bigger type of game. For small games, the solution works flawlessly. You're going to have the modules implemented the way you want, but if you want to make faster games and more performant, the issue you're going to have is that nodes have a lot of resources you're not going to use. If you are just using nodes to apply this type of situation, which is through modules, logic modules, let's say, then all of those functionality you're not going to use, but they are still going to be called when you start your game. So for instance, if you have 100 units which have 10 logic modules, so let's say move, attack, movable, destroyable, etc. Anything you want to group together through modules, then each unit has 10 modules. That means 10 additional nodes. Now if you have in your game 1000 units, you're going to have 10,000 nodes just for the units. So you can see how this can grow towards becoming a performance issue. So the idea here is that it works but you are going to pay a price through performance cost. So if your game is small, then I could potentially recommend this, because it is a great solution for small games. If you are making bigger games, then this might not be the best solution. So that doesn't mean just because you have a lot of nodes that the game is going to be slow. You could use fewer graphical resources, and this in turn could make your game work. So this is not a rule. This is just a common estimation that if you have a lot of nodes, like thousands of nodes, like 10,000, 20,000, you're going to face issues. Despite if your game is 2D or 3D, doesn't matter. You are going to face issues of slowdowns because it's just too many nodes for the engine to handle. And this is not particular to Godot either. In any engine, you're going to face the same issues. And here are some good news for users of Godot. Godot is developing a trait system. Our beloved Venin is just about to implement a trait system for GDScript. So this would allow us in Godot to do multiple inheritance through a traits method, and I recommend you to read it as well. It is on the number 6416 on the GitHub proposal of Godot. So I'm going to try my own system and see how it works. Depending on the situation, we could probably adapt later to the trait system. So I think this is some good news for Godot users that I should be sharing with you guys. So this is just a little bonus. So let's talk now about method C. So method C, which uses a ref counted data scripts. And this is the one which are going to apply to our RTS project and try to build a system around, because I think it's the more robust, the most light system, and is going to perform the best. And it's also a great way for me to group the different elements of the RTS project. So here is how it could potentially work. We have here a couple of things. We would have, let's say, a standard soldier unit, and this will belong to an attack unit class. So this is like a mixture. We could mix some classes and some modules together. So the idea here is just to see what works best for us. So this class, which is the attack unit, we could extend a special unit, which could be a hero or a unique unit to a faction, something like that. And in our case here, let's say it is our Josh soldier unit. And we wanted to give it some special ability, which is different from all the soldier units. Well, we just could implement throw grenade module, for instance. And this is a module just like all the other modules. Because this module is, let's say, pluggable, we are using them inside the class, but also we can use it inside the script. So this idea is almost like multiple inheritance, and I think it works the best way. So we're not changing here how the system behaves. We are just changing the idea of how it is applied. So we're still using a module component system. And here's another example of how this could potentially work. Let's say you have a building. And we detect when the HP is less than 1, so the HP reaches 0 when we want to call for an explosion effect. So the building is requesting an explosion, and this request could be handled by an explosion module, which is going to select the explosion type that the building requested and create an explosion. So basically we are grouping some type of logic together and calling a module. So the idea is tiny bits of script that are working together from separate and isolated places. There are some trade-offs with using the system. We are going to make most of our code do some abstract functionality, so it should work with every node. That isn't so hard to do, but it's a little different. And we can also limit our scripting performance here. Instead of holding variables to the logic, we can work only with static functions. And here is how it works. Unless you type new after preloading a script, it creates a new instance that can hold properties. So we want to avoid that in order to achieve more performance. So I'm going to see if I can work only holding variables inside a single unit. And we are going to try to work all the codes through static functions. We're going to need interfaces, so the modules will need interfaces to operate inside that variables, which are going to be inside the units. And this is a limitation that I impose to be more performant, because if you have variables and you are instancing the scripts, you possibly could reach a situation just like the node which you talked previously. You're going to have too many instances just to manage a couple of variables. So I'm going to try to hold all of them inside a single unit. So a module could manage indirectly something by giving a procedure to follow, almost like a recipe. Through this system, we can somewhat manage variables through the static typing functions. For instance, we can use metadata to add information about a unit inside, which is basically adding a dictionary, and we can store our values we want right there, and through the scripting of the modules, we can manage those types, and we can keep track of the metadata constants in a separate class to avoid messing things up. Later, when you want to change their name or stuff, all of them are inside a single place. So it's a good idea for us to group a lot of constants together, like the variable names, let's say. So when we change something inside the metadata, all of them are referring to that constants manager. So basically, modules should avoid interacting with other modules. While we still can load them and run their functions inside other modules, we want to make something like a library of books. So a book should not be able to read other books, but someone could go pick a book and use it. There's no right way of doing this. This is just the way that I think are going to work best for my situation, for my workflow. We only want functions to be applied. We shouldn't want a new command because it's going to create an instance of that. So if we want only functions to be applied through our modules, we shouldn't do a new command because that is going to create a new instance after loading the script. So if these situations apply, we can use only static functions. However, if we want the script to hold some variables information, then we should do a new command. And this allows us to store variables outside of the function scope of the modules. By not declaring and extending a script file, so just like this example here, automatically it's inheriting from the ref count type. And if you don't know what a ref count type is, it's a base class for any object that keeps a reference count. This is a reference from the documentation of Godot, which you can find under classes, class ref counted. So what this basically means for us is that, let's say we have here and give an example. We have a sound which we created from a master. So if you don't know, Godot outer stream inherits from resource, which in turn inherits from the ref counted. So when the sound is no longer in use, it's going to automatically be freed. That's a common behavior for any resource inside Godot. So let's see now the object class. So this is the base class for all other classes inside the engine. So you can create a new instance using object.new. So this is a common thing that most of the people do. They load and script and type .new. Now, what you should notice is that unlike the ref counted objects, the pure object class does not delete itself. And this makes sense. For instance, if we make a game, so let's say we have a player which is on sprite 2D. We only want to delete the player when we want, not if it's not being used. So this makes sense. You do not want Godot to delete any node automatically because you want yourself to determine that logic. So let's say you finish a level, then you probably want to delete a node to change the screen, go to a new scenario, etc. So this doesn't make sense for nodes, but makes sense for resources. So the memory is managed through this type of behaviors. So if you're using ref counted, it will behave like a resource. No longer in use, then it's going to be deleted. And if you inherit from the object type, then it's going to work like most nodes. They are not going to be deleted unless you type. And this is important because if you add two new objects inside the same variable, the first one will never be free and it is going to remain as a memory leak. So this is quite important to know. So what all of this mean to our design idea of modules? If something inherits ref counted, it's going to automatically delete it when not in use. And the example for this is resources, which inherits ref counted. So if an object does not inherit from ref counted, it's going to behave like a node. So you are going to need to delete it manually. And this we do usually through scripting. And this behavior is applied if you, for instance, extend from an object. So a lot of people usually go and extend from the object class. But you have to know this difference from the object class to the ref counted, because I think the ref counted class is better applied to those scripts. So for our system, using ref counted scripts will work the best way. When they are no longer in use, they are going to be automatically deleted. So this will be the system that I will try to implement in our RTS project. And that ends the video. I'll see you on the next one.